What I would like to do is I would like to just maybe go to the last worksheet. All right, I'd like to go to the last worksheet. All right, so we can talk about it real quick and just make sure you guys get it completely. All right, so for question number 1, x would be what? 25 radical 2. All right, bless you. Number 2, x would be
17
good, but I'd first like for you to say it's 17 divided by radical 2. Everybody with me on that? And then when you rationalize the denominator, we would say it's 17 radical 2 over 2, or she's correct, 8.5 radical 2. All right, but we just don't use decimals. All right. Number 3, x would be what? 48 radical 2. Come on, please, pay attention. All right. Now, again, some of you are understanding now. You see the pattern. All right. Instead of dividing by radical 2, it's always multiplying by radical 2 over 2. If you see that pattern, that's perfectly fine. If not, I never really like to do that because in a couple of weeks, you're probably not going to remember that. All right. I would prefer that you just say it is 100 divided by radical 2, which then simplifies to 50 radical 2. Do we have any questions with that? All right. So let's drop down to the 30, 60, 90 stuff now. All right. So x is what in number 9?
44 radical.
Wait a minute. 22.
And then y would be
11 radical 3. All right. Again, if you know the rules, it's just simple. Simple. All right. So let's look at 10. So the hypotenuse is 8 radical 3. So y is what? What is that? 4 radical. Yes, 4 radical 3. Now here's where you might be a little sketchy with your remembering radicals. So let's figure that out. Any questions? And now to get from the 30 to the 60, you multiply by radical 3. Well, what is radical 3 times radical 3? Radical 3 times radical 3, I just want you to say is 3. I don't want you to say radical 3 times radical 3 is radical 9. Anytime the radical is multiplied together, that's what you're doing. You're eliminating the radical. Right? Exactly. So the answer here is 12. Do you have any objections? It's 4 radical 3 times radical 3. And 4 radical 3 times radical 3 is 3. 3 times 4 is 12. All right? That's why we're doing this to review. All right? So y would be what? 10 radical 3. And then x would be what? 15. Now, those of you guys who are not with me, it's like I said, I keep trying to tell you, you're not doing yourself any favors just writing down the answer. Just not. Because radical 3, this is what I'm doing to get that. I'm multiplying that by radical 3. Right? Yes, perfect. All right, so here we go on number 12. All right, so x would be what? 15, and y would be 15 radical 3. Simple as that. Over here, x would be what? Or I'm sorry, y would be what?
21.
Everybody agree with that? 21. Come on, I'm telling you. Listen, is this the 30 or the 60 side?
630.
They kind of made a mistake on this one. Hold up a minute. Does everybody agree they made a mistake?
Yeah.
This is definitely the what? That's definitely the 60. And this is definitely the what? 30. All right? Everybody good with that? Yes, you absolutely do.
So y would be 21.
21, right? Do you agree with that? To get from the 60 to the 30, you divide by radical 3. And then x would be what? 42. All right. Okay, so in this case, y would be what?
No.
What would it be? 26 radical 3.
Oh, because
Just half. Just 78. Perfect. With radical 3 again, times radical 3 is 3. And 3 times 26 is 78. All right? Anybody got any questions? All right, thank you. Let's pull up 8.4 now. Okay, so again, I definitely am going to need your attention here for a second. What I want to do in this case is I'm going to go ahead and add a page, and then I'm just going to go through it myself. And then you can, if you want, just refer back to that. But again, listen to me. Trigonometry was a big breakthrough. All right, they figured out that if you know the angle to actually any triangle, but right now everything's going to be limited to a right triangle, then you can figure out everything there is to know about the triangle. All right, so let me try to explain exactly what's going on. All right, so I prefer if you just listen real quick, just put everything down and concentrate on what I'm saying. All right, just concentrate on what I'm saying. All right, this right here is a right triangle. All right, we know that this is called the hypotenuse. All right, earlier I said there's a short leg and a long leg. Well, now we're going to be specifically talking about an angle. All right, we're just going to call this angle x. From x perspective, this is the opposite leg. And this is called the adjacent. All right. Now, if I were looking at y from y's perspective, does the hypotenuse change? No. But the adjacent becomes the what? The opposite, and the opposite becomes the what? That's where all the mistakes come from. So right now, I just want you to get that into your brain. If I say the opposite, you can't just tell me a side. You have to say the opposite of what angle. You have to say the adjacent to what angle. Does everybody hear me? All right. So now, what they did now, and I'm just going to go from x perspective, is they figured out that regardless, and you will understand exactly what I'm saying, if I make this right here, and I make this right here, right? And let's just say, for example, I call this A and this B, and I call this C, and I call this D, and I call this E, and I call this F. What is true about A over B, C over D, and E over F? They are exactly the same. Because those triangles are what? Similar. So the ratios are the same. We learned that last semester, which I didn't think was that hard. Can I agree? So believe it or not, this angle, all right, this ratio A over B, all right, is defined as the tangent. All right. Now there's lots of names for tangent, but this is one. All right. We are going to define the tangent of the angle. And this is where we talk about trig. Tangent, sine, and cosine are trig names. All right. It's just a description of the ratio, of a specific ratio. When I talk to you about tangent of x, you know I'm going to referring to the opposite over the adjacent. I'm also going to talk about the sine of x. And the sine of x has a specific name, all right, or a specific ratio. The sine of x is defined as the opposite over the hypotenuse. And then we're going to introduce cosine of x, and they label it cosine of x, and the cosine of x is the adjacent over the hypotenuse. All right? So generally the way your math teachers will talk next year is they will say this kind of abbreviation. Sakatoa. All right, very good. All right, they give some Indian chief the name. All right, Chief Sakatoa was the one who invented all of this trigonometry. All right, so this stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So Sakatoa is how you can remember that. Or if you're going to plant, they will teach you this. They will tell you that some old hippie caught another hippie tripping on acid. All right? That's what they will tell you at plant. All right? For those of you guys who are going to plant. Some old hippie caught another hippie tripping on acid. If you go to any other school, they will be talking about Chief Sakatoa. All right? He will be the one that's given credit for the trigonometry. All right? So again, I need you to understand, when I say sine, I'm referring simply to the ratio of the opposite over the hypotenuse. If I ask you about the cosine, that is simply asking you about the ratio of the adjacent over the hypotenuse, and tangent is referred to as the ratio of the opposite over the adjacent. All right? Now, a long time when I was in high school, we had to actually use tables because calculators were first coming around and they were super expensive. All right? So we had to look up in tables all the information. Well, now that you have your calculators, all the information is stored on your calculator. So again, for every single ratio of sine, cosine, and tangent, it can give you the angle that corresponds to that ratio. All right, which is extremely beneficial. All right. Now, what I want to do is I want to kind of go back now and I kind of want to look here. So, from Jay's perspective, all right, from Jay's perspective, and the next thing I want to do, which I think is kind of dumb, is, does everybody agree that this is a multiple of 4, right? Yeah. So cross this out and put a 3, 4, 5. That way you don't have to reduce the fractions at the end. Or you don't have to reduce the fractions at the end. All right? Yes. So in this case, they're going to ask you for the sine of j. So sine of j is equal to what? Which is 3 over 5. Cosine of j.
4 over 5.
And the tangent of j.
3 over 4.
Now again, that's trig. All right, a little bit more complicated because they don't always give you the angle or the side, which we'll figure out. All right. So now, from L's perspective, if I said the sine of L, you would say the sine of L would be
4 over 5.
Exactly. And the cosine of L
3 over 5.
and the tangent of L.
4 over 3.
Everybody happy with that explanation?
Really good with that.
That's good. That's all you need to know. You're just practicing the definition right now. All right, just practicing the definition. All right. So now, let's look at number 3.
We can't do it.
Oh, very good question. No, very good question, actually. All right, the reason because the opposite is the hypotenuse. That makes sense, right? All right, very good. All right, so over here I'm going to divide by what? We're on number 3. All right. I just divided by 12. Okay, so now if I said, stay with me, sine of L, what would the sine of L be? Which is the same as 1/2. Everybody good with that? Cosine of L. Look at what I did for the can't have a radical in the denominator. Yes. All right, now we're going to look at the tangent of L. I'm listening. I didn't do 2 times 3. I left it 2 times 3 because I knew I was going to cross out the 3's. Right? All right, tangent of L. What's tangent of L? Radical 3 over 3. Everybody good with that? All right, let's do sine of J. Can anybody tell me what the sine of J is without doing the problem? Believe it or not, it's the cosine of L. Everybody looking at that? That's correct. Square root of 3. And then cosine of J
Is the
sine of L. For those guys who are interested in patterns. And then the tangent of J is the reciprocal. Am I good with that? So look at the relationship. Look back. I want everybody to look at the sine of L and the cosine of J. What are they? Sine of J and the cosine of L. They're the same.
So you really only have to do the one for one.
Yeah. If you're thinking about it. All right, yes.
Wait, so then if you were going to do, the first problem A.
We already had that conversation, believe it or not. We can't do, right?
The opposite.
I'm listening. Tangent of J. Because radical 3 times radical 3 is 3. Right? Okay. All right. Now, here we go, guys. All right. What time do we get out of here, guys? All right. So, how much time do we have? All right. So here we go. Now, I need everybody to take out your calculators, please.
It's too hard. It's like so hard. Yeah, even Wait, have you heard the song where it's like, No, okay,
I love mine.
It's like an old song. This one's good.
I like song I told.
All right, here we go. All right, now the important information, all right? Okay, so number one, all right, I'm actually going to have to find the exact measure of angle T. I'm going to find the exact measure of angle T. All right? Now, most of the time people feel like it's either a 30 or a 60 or a 45, but it's not the case. Most of the time it's not a 30, 60, 90. All right, and I'll show you why we have made that so it's unnecessary if you understand trig. All right, but I need everybody to hit the mode button on their calculator. Mode. All right. Now on mode, guys, I don't have much time. Mode. All right. Now on when you hit the mode button, all right, there's something that comes up: degrees, radians, and we want everything done in degrees. All right, you'll learn about radians when you take pre-calculus. Right now, your calculator needs to stay on degrees.
Do we hit enter?
Enter. All right. Most of the time, the calculator starts on radians because that's the most common form. All right. Right now, we're in degrees. The reason we're talking about degrees is because we're talking about the actual degrees of a triangle. All right. Now, listen carefully. I'm trying to figure out what T is. So here is my recommendation. Angle T is what I'm looking for. They give me 14 radical 3 and 34. Your job is to identify what 14 radical 3 is and what 34 is with respect to T. The 14 radical 3 is the what? Opposite, and the 34 is the? Therefore, you know you're using the what? Tangent. All right, so please listen. All right, tangent. All right, so we say the tangent of T. After you write a trig function, you're writing a variable. In this case, the angle. Tangent T is equal to 14 radical 3 over 34. Does anybody have any questions with that?
Why are you using tangent?
Which one would you like to use?
Just like, how am I figuring that out?
I showed you right up on the board. You identified the opposite and you identified the adjacent. So what trig function
Oh, okay.
is for opposite and adjacent? That would be tangent. All right, so you write it out just like that. Now, the mistake most people use here is they're solving for T, so they think they divide by tangent. That is completely untrue. So listen to what I'm telling you now. All right, I'm trying to get to T. So how do we undo addition? We do subtraction. Multiplication we do. Square we do. Square root. If I ask you cube, you would tell me cube root. So if you look on your calculator, all of those are there. All right, eventually you'll learn log and 10 to the x. Then you learn ln and you'll see the e. They're stacked on top of each other. The reason why they are stacked on top of each other is because they cancel each other out. Listen to what I'm saying. They are inverse functions. So if they give me tangent x, I have to get rid of tangent. So I have to take the inverse tangent. Now I'm going to show you mathematically up on the board. So look up so you understand. All right, I'm trying to get to T. I don't divide. I don't multiply. All right, the inverse is what I'm doing. Now I prefer that they would use a different symbol for inverse. But the inverse is written as this, tangent to the -1. Now, the reason why I don't like something to the -1 is because that is already a mathematical operation, so it is confusing to kids. But tangent to the -1 in this respect means inverse. All right? Now, what happens to the inverse tangent and tangent? What do they do to each other? They cancel each other out. So I'm just left with what? T. Now, I'm going to do this. All right, please pay attention because I'm going to slide this over. If I take the inverse tangent of the left side, I have to take the inverse tangent of the right side. So I would put tangent -1 there. So now T is equal to, on your calculator, you hit second tangent. You hit the second tangent, and then you type in 14 radical 3, and then divided by 34. Now, if you have an old calculator, sometimes when you hit square root, the parentheses comes up.
Yeah.
All right? If the parentheses comes up with the square root, you have to close the parentheses.
35.496.
Wait, what do you do?
Yeah,
When it comes up with the
35.5.
parentheses?
Close it. So it's going to be 35, and we'll just, in geometry terms, it doesn't really matter what you're rounding to.
Not 2.
So 35 point, tell me again.
496.
Let's say 35.5 degrees for now.
I don't.
Super, super important concept. So here we go. All right, inverse tangent. So it should be second tangent, and then 14, and then do radical 3.
You do a space.
And then divided by 34.
I think you get 2.5. I got 2.5. Cool. I got 35.4.
That's what it is.
Yeah.
Okay, so I understand what some of you didn't understand what I was saying. So please look up on the board. Look up for a second. When you hit in the old calculators, it was like this. I don't think you guys have that anymore, right? When it hits square root, it doesn't. Okay, so if it does do that, then you have to close it. Because if not, it will do, it'll continue doing the square root of whatever you put after that. Does everybody understand what I'm saying? All right. So here we go. Let's look at question number 2. So number 2, I'm circling T, I'm circling 7, and I'm circling 18. And you have to tell me what 7 is relationship to T. That is and 18 is the, so opposite over hypotenuse is what? Sine. So you would write sine of T is equal to 7 over 18. Now, I would prefer if you just write T equals inverse sine of 7/18. And somebody tell me.
I have a question.
Just grab a calculator up on my, come on, man. I don't hate you sitting there.
22.88. So 22.9.
What is it?
22.9.
Somebody said about 22.9 degrees.
That's someone's turn.
Really?
All right, here we go. Shh, 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 shh. Again, question number 3, guys. A lot to do. Just look up on the board, you guys. There's too much interruption now. All right, you asked me a question. All right, I'm on number 3. I'm still doing T. 34 and 87. 34 is the, and 87 is the, so we are doing what? Cosine, that is correct. Cosine of T is equal to 34 over 87. 34 over 87. So T is equal to the inverse cosine of 34 over 87. So T is approximately what?
67.
66 point what?
99.
All right, so 66.99 is about 67 degrees somewhere. No one's telling a joke. We're paying attention. That's what we're doing. Stop focusing on the joke. Number 4. Again, we're angle T. We're looking at the relationship between 32 and 101. Adjacent and hypotenuse. So, adjacent is what?
32.
cosine of t is equal to 32 over 101. T is equal to inverse cosine
71.5,
which is approximately
71.
71.5 degrees.
What's the Indian person's name?
Sakatoa.
Sakatoa. That's racist. It's Native American.
All right. Thank you. It wasn't a Native American. All right, here we go. Angle T. Here we go. T is what? Cosine of T is equal to 10 radical 3 over 67. All right, so here's another radical. Make sure you can do this. So T is equal to inverse cosine
75 point. It's just 75.
roughly 75 degrees.
Yep.
I got no syntax error.
95.0.
Syntax error just means you typed it in incorrectly.
Yeah, I mean, he's the year of the error. Stop. It's 10 radical 3.
No, if you're,
I did click.
you can't type it while you're still in the back. It's like do the arrow outside the back. You can't write 10 radical 3.
How do you do it? Oh, I haven't old
It's 75. I'm gonna say.
Okay. Now do me a favor, please. Look down at 8-4 skill practice. I want everybody to look at question number 30. I'm sorry, number 3. Everybody look at number 3 real quick. Now these are just practice. All right, I don't care about the direction. Just type in sine of 30 degrees. And you should be able to tell me that's 0.5. Everybody type in the tangent of 45.
One. Oh, you literally just put cos 60. Oh, my.
Cosine of 60 is what?
0.5. It's like a thing. Why do I need?
All right.
Oh, jeez.
Now,
What if it's like a really weird one, like 0.8866?
you should have known that's square root of 3 over 2.
Yeah, Reagan.
All right, or you could round it to the nearest hundredth.
That's happening.
All right, so I need everybody to stop now and look at number 9, the last example problem I need to do. All right. Now on number 9, all right, in the previous problems we were looking for angles. You now are able to figure out the side measure or the angle measure, all right, if they give you an angle. So, for example, look at number 9, all right? I have 3 things, 36, 7, and an unknown. Your job is to tell me what is the relationship with x to angle 36. It's the opposite, and the 7 is the
Adjacent.
so we know we're going to use tangent. All right, so now listen to me now. The last thing, we're running out of time. Every single time you write a trig, you have to write an angle. All right, so is the angle unknown?
No.
No, the angle is
No.
36. So you're going to write tangent of 36 is equal to x over 7. It's just algebra. So now what we're doing is we're saying it's just kind of a proportion, or you can say I'm just multiplying both sides by 7. So x is equal to, type in on your calculator, 7, not inverse, 7 tangent 36.
Oh,
The reason why it's not an inverse is because after the trig comes the angle. You're not looking for an angle. They give you the angle, which is
5.08.
5.08. So in this particular case, 5.08. So again, what I'm trying to explain to you is, listen to me. Believe it or not, trig is super powerful. All right? Eventually, when you take pre-calculus, you'll get involved in the non-right triangles. Your job, listen to me, guys. Hear me out. I want everybody to do 8.4 practice. 8.4 practice, and I'll be checking that tomorrow. If you need a little bit of extra practice, you can kind of look things over.
Plus the word problem.
Yes, do the word problem. The word problem is not hard. Just this, 8.4 practice. I know there's not a practice. The other's not called practice. Skills practice. The last one.
All it is just having the calculator.
All you have to do is switch the little thing to 3, and you're good. And then you just type it in. You have no calculator.
Mr. Shaw, I remember this from when I took the ACT class.
Why do you like holding it back? Oh!
You don't know.
Yes, you are.
What if you miss one?
I'm just one that you'll protect her. Does that make sense? Because he's a junior.
Oh.
It makes sense now. I'm gonna look up the number of ginger cake crowns there before. I'm curious, Isaac. Aren't you?
I'm just a boy.
No. Oh,
I'm just a boy.
Guess what?
oh, you did.
You guys can stay in here if you want.
Wait, look at the first article. Look at the first article. She's a pig. They don't want to use food.
Starting
Why do you say that? Oh my god!
I might see.
My cheek just
Give her 2, you give me 1.
I'm so gross. You're like real baby. I need a sweet thing.
You still got 2, that's there.